So for this project, we created a digital etch-a-sketch using C coding for our CPE 185 and electrical engineering 174.
Okay, the project is meant to implement a finite state machine program on a STM-L432KC Nucleo board. The project was to create a simulation of etch-sketch toy, allowing for an image to be drawn using 4 inputs instead of the 2-button dial that we're used to, and allowing for a 5th input to clear the image, which is akin to shaking the screen. The image is drawn on an OLED, which is a 32 times 188 display. The image will stay on the screen until it's cleared by pressing a button. A button on the screen will be visible at all times where the pixel will be drawn, and draw using the 4 movement pins by varying the coordinate on the pixel of the OLED by 1 pixel per button press.
So the hardware that was used in this project was the STM432KC Nucleo board, one or you could use 2 solderless breadboards, the OLED, 5 push buttons, 5 330 ohm resistors, 16 male to jumper connectors, a computer, and a USB to micro B cable.
And the software that we'll be utilizing is solely the STM32Cube IDE, using the workspace 1.112.
So for the wiring, we had the buttons hooked up in series with the power and the ground with a 330 ohm resistor going to ground. For the OLED, we used I2C integration going to the pins on the STM board.
Yeah, and for the pinout configuration itself, if you look at the picture, we have 5 GPIO inputs using PA1 through PA5, and we'll also be using, for the OLED, we'll be using the I2C for pinouts 9 and 10.
So the library that we used to implement our project was gotten from a GitHub repository that allowed us to use a lot of the functions that were used in our code. The code from the GitHub repository was copied into a .h file or a .c file, respectively, in our code so that we could implement it.
One issue that we came across during the writing of our code was the variables. When we attempted to create a variable within a state, it can only be used or altered within that same state. So instead of declaring the variable within the state, we tried declaring it outside the state, which also caused some issues. We ultimately ended up creating and declaring variables globally in a .c and .h file so that they could be used and altered in all states of our finite state machine.
So the finite state machine that we had originally designed would basically go from which button press was pressed into their respective states and back to the draw state where it would draw the pixel at that XY coordinate. Other than the clear state, which would clear the entire OLED by making it just all white.
For the code in the main.c file, to declare the state handlers and the states of the FSN, initializes the OLED and creates the finite state machine. The finite state machine utilizes the library and the global variables to interface with the OLED and move the drawing variable pointer around the screen. Each button changes the state of the finite state machine, then returns to the default state of the code.
So the difficulties that we had while creating this project, the original project that we were going to create was a Tetris simulation on an LCD display. First, there was the issue of creating custom characters and displaying them on the LCD. From that setback, we realized that the OLED would be much easier to use as the output from the project because you could change the individual pixels. The FSM for the Tetris code would have gone through a start, drop, rotate, clear, and end phase. While we were able to create the start, end, rotate, and part of the drop states, it was extremely difficult to get the blocks to stop on each other and to know when they had reached the top. It was definitely possible, however not within the time given, as it would take a large amount of code. So rather than continue on with the project, we decided to use all of the learned processes from the Tetris code to complete the Etch-a-Sketch project.
In conclusion, using the design and the concept of Etch-a-Sketch toy, we wanted to recreate that we created using the finite state machine, explained in the prior FSM code. We made it not with 2 dials, but with 5 buttons instead. And with the STM regulating the GPIO pinouts and the STM Cube IDE program managing the code, we were able to recreate the toy known as Etch-a-Sketch. Even though the program seemed simple enough, plenty was learned through implementation and design. As stated in the difficulties, we changed it from Tetris because it would not have been achievable in our given time frame. We're happy with the results, and we can now draw on our digital Etch-a-Sketch toy.